Today we are going to graph quadratics from Vertex form, but before we do that, we are going to look at each transformation to see how they change our graph, starting with number 1. Number 1 is the function y equals x squared, and this is a very important function because it is our parent function for quadratics. Every function is going to be compared to this function right here. They all come from this function. So in order to graph this by hand without a calculator, we are going to make a table. And for our tables today, we're going to go from -3 to +3. So I'm going to plug these in for x and see what y's I get. If I have -3 squared, that's going to give me +9. -2 squared is going to give me +4. -1 squared gives me +1. 0 squared gives me 0. 1 squared gives me 1. 2 squared gives me 4. And 3 squared gives me 9. When I plot these points on my graph, and if you need to pause the video to plot them on your graph, that's totally fine. You will notice that they are symmetric around our y-axis. You can also notice that on the table, if my vertex is 0, 0, the 1's match, the 4's match, and the 9's match. All of your quadratics are going to be symmetric around your axis of symmetry. So looking at number 2, it's very similar, except now we have y equals -x squared. So to graph this one, we are applying a negative in front. We're going to use the same x values, but we're going to see what that negative will do to our graph. So if I have the opposite of -3 squared, it's no longer going to give me +9, but now I have -9. -2 squared is +4, but then when I apply the negative in front, it becomes -4. Very similar with -1, I get -1. 0 is going to stay 0 because there's no such thing as -0. The opposite of 1 squared is -1. The opposite of 2 squared is -4. And the opposite of 3 squared is -9. So basically that negative in front has made all of my y values negative. Let's see what that looks like when we plot those points. If you need to pause the video to plot these, go for it. We have 2, -4, 3, -9, -2, -4, and -3, -9. So by applying a negative in front of the x squared, it has flipped our graph over the x-axis. This is called a reflection. So if you go to the back of your paper, where we have our list of transformations, we just found our first one. Our first transformation is that a negative in front causes it to reflect over the x-axis. It makes it now go down. Let's look at our next one. Our next one is x squared minus 5. And again, we're going to use the same x values. We're going to go from -3 to +3. And this time, I'm plugging in my x, but then I'm subtracting 5 from it. So -3 squared is 9. 9 minus 5 makes this now a 4. -2 squared is 4. 4 minus 5 now gives me -1. -1 squared is 1. 1 minus 5 gives me -4. 0 squared minus 5 is -5. 1 squared minus 5 is -4. And so on. We get -1 and 4. Let's see what this looks like when we plot our points. I have 0, -5. I have 1, -4, -1, -4, 2, -1, -2, -1, and 3, 4, -3, 4. If you compare this with our parent function, you will see that it has been shifted down 5. So subtracting 5 made it shift down 5. Let's compare that with number 4. On number 4, if I make my table and use the same x values, this time, negative 3 squared plus 5 would be 9 plus 5, which is 14. Negative 2 squared plus 5 would be 4 plus 5, which is 9. Negative 1 squared plus 5 would be 1 plus 5, which is 6. 0 squared plus 5 would be 5. 1 squared plus 5 would be 6. 2 squared plus 5 would be 9. And 3 squared plus 5 would be 14. If you plot those, you have the points 0, 5, 1, 6, negative 1, 6, 2, 9 is a little bit off our graph, and negative 2, 9. Since 3, 14 is way off our graph, we won't plot those two. So comparing 3 and 4, you can see that the minus 5 moved our graph down 5, and the plus 5 moved our graph up 5. These are our next two transformations. X squared minus 5 means my graph will go down 5. X squared plus 5 means my graph will go up 5. Now, notice that this minus 5 and plus 5 are outside of the parentheses. Our next two transformations have parentheses, so let's see how that changes our graph. Looking at number 5, I'm going to use again the same x values. We're going to go from negative 3 to positive 3. And now if I plug this in, you have to be careful with using your parentheses. Negative 3 minus 1 is negative 4. Negative 4 squared is 16. Negative 2 minus 1 is negative 3. Negative 3 squared is 9. Negative 1 minus 1 is negative 2. Negative 2 squared is 4. 0 minus 1 is negative 1. Negative 1 squared is 1. 1 minus 1 is 0. 0 squared is 0. 2 minus 1 is 1. 1 squared is 1. 3 minus 1 is 2. 2 squared is 4. And we're actually going to do one more. Plug in 4. 4 minus 1 is 3. 3 squared is 9. So go ahead and pause the video if you need to plot your points. We have 3, 4, negative 1, 4. We have negative 2, 9, and 1, 2, 3, 4, 9. All right, so if you compare this with our parent function, this minus 1 in the parentheses didn't move it up or down. Instead, when you compare this to the parent function, the minus 1 in the parentheses actually moved it to the right. We moved every point right 1. Let's compare this with number 6. On number 6, if I go from negative 3 to positive 3, negative 3 plus 1 is negative 2. Negative 2 squared is 4. Negative 2 plus 1 is negative 1. Negative 1 squared is 1. Negative 1 plus 1 is 0. 0 squared is 0. 0 plus 1 is 1. 1 squared is 1. 1 plus 1 is 2. 2 squared, is 4. 2 plus 1 is 3. 3 squared is 9. And 3 plus 1 is 4. 4 squared is 16. If I plot these points, I have negative 3, 4, negative 2, 1, negative 1, 0, 0, 1, 1, 4, and 2, 9. If I keep this symmetric, I would also have negative 1, 2, 3, 4, 9. So when I compare this graph to my parent function, the plus 1 in the parentheses actually moved it to the left one. It's important you know the difference between 3, 4, and 5 and 6. If your number is in the parentheses, it's going to move it left and right. If it's out of the parentheses, it's going to move it up and down. There's also one more special thing that you need to look at for 5 and 6. Minus 1 in the parentheses you would think would mean to the left one, but it's actually the opposite. In the parentheses is opposite of what you would think. The minus 1 actually means we're moving everything to the right one. The plus 1 means we're actually moving everything to the left one. These are our next two transformations on our list. X minus 1 squared means I am moving right 1. X plus 1 in parentheses squared means I am moving left 1. Now we're to our last two transformations. So starting with number 7, I'm going to use the exact same x values. We're going to go from negative 3 to positive 3 again. And this time I have a 2 in front. So I'm multiplying everything by 2. Well, negative 3 squared is 9. 9 times 2 would give me 18. Negative 2 squared is 4. 4 times 2 would give me 8. Negative 1 squared is 1. 1 times 2 is 2. 0 squared is 0. 0 times 2 is 0. 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. And 3 squared is 9. 9 times 2 is 18. I'm only going to plot what I can fit on this graph. So I have 0, 0, 1, 2, negative 1, 2, 2, 8, and negative 2, 8. When you compare this with your parent function, you can see that the 2 in front actually made it skinnier. This is called a vertical stretch. If you think about a rubber band, if you pull the rubber band up really high, it gets skinnier. That's what's happening here. The vertical stretch, when you stretch it up, it makes the graph get skinnier. Multiplying all the y's by 2's make the y's speed up and go higher faster. That's what's making it skinnier than what our parent function looked like. Let's see what 1/2 in front will do to our graph. Now, since we're having to cut our x value, or since we're having to cut everything in half, we are still going to use the same x values, but I'm actually going to add one more to help you visualize what's going on here. So for this one, we're going to go from negative 4 to positive 4. So by plugging in negative 4, negative 4 squared is 16. Half of 16 is 8. Negative 3 squared is 9. Half of 9, I'm going to put as a decimal, is 4.5. Negative 2 squared is 4. Half of, oops, I put a 4 when I said 4. Half of 4 is 2. Negative 1 squared is 1. Half of 1 is 0.5. 0 squared is 0. Half of 0 is 0. 1 squared is 1. Half of 1 is 0.5. And so on. You'll end up getting 2, 4.5, and 8. Now, when you graph these, we have negative 4, 8. We have negative 3, 4.5. You can just put that in between 4 and 5. We have negative 2, 2. Negative 1, 0.5. 0, 0. 1.5, 2, 2, 3, 4.5, and 4, 8. If you compare this with our parent function, the fraction in front has actually made the graph get wider than our parent function. Our y's are growing slower than our parent function. This is called a vertical compression. If you think about the rubber band, if you press a rubber band down, it's going to get fatter. So comparing the two, if you have a whole number in front of x squared, that is going to make it skinnier. That is going to be a vertical stretch. If you have a fraction in front of x squared, that's going to be a vertical compression. That's going to make it wider. So we're going to update our list. For 2x squared, that is a vertical stretch. If you want to put skinnier in parentheses as a reminder, you can. For 1/2 x squared, that is a vertical compression. In other words, it's going to get wider. So in order to move on to our next set of graphing, you have to know these transformations. So make sure you memorize them, and if you ever forget, you can always make a table and compare it to our parent function. The most important thing you need to have memorized is our parent function, which is y equals x squared. This is part 1 for graphing quadratics in vertex form. The next video will go over how to graph with multiple transformations at once.